Right. Today we're going to solve a couple of the exercises from logarithmic equations and exponential equations, and then we'll start the new chapter 5, inshallah, 5.1. Now, if you look at this problem here, Shabab, you see 1/3 here. Basically, we can use it as a power of 2. So the 2 becomes 2 to the power of 3, 2 cube. All right. So it becomes a logarithm with base 8, right? So therefore, Shabab, we can just write it again. Logarithm of base 8, x plus 5, and plus logarithm 3x minus 1 with base 8 equals 2. So we got the same base 8 here and here. You see that? Now the rest is easy, of course, because we will just multiply the arguments of these two logarithms. And after that, we have to switch to exponential expression. That means x plus 5 times 3x minus 1 equals 8 square, which is 64. And we just multiply these brackets by following the distribution rule. And then when you organize it, you will get 3x squared plus 14x minus 69 equals 0. And the factorization of this quadratic equation is 3x plus 23 and x minus 3 equals 0. And now we have two solutions. We have negative 23/3 and 3. And as you see in the original the equation, Shabab, we cannot replace x with negative 23/3, right? If you replace it with negative 23/3, then logarithm of negative numbers will be undefined, right? So negative 23/3 is rejected, but 3 is the only solution for this equation. All right, Shabab, is anything clear here?
All clear.
About 1/3, how did we make it a power?
Shabab, if you have a logarithm here with 2 power 3, so it becomes 1/3 times logarithm with power 2, right? This is the property of base having a power. All right. So
Okay.
this one is the same as, logarithm of with base 2 power 3, which is 8. Okay, basic principle of base, Shabab. Okay, shall we go to next page, Shabab? Here we have logarithm with roots, but two roots are in different positions, Shabab. In the first, on the left side, we have root of logarithm. On the left side, we have negative logarithm of root x. So, of course, we need to remember the root of x is just the x to the power of half, right? And you know that if you have x to the power of half, that comes to the just behind the logarithm. And you just need to write negative half times logarithm of x. All right, is this clear? And on the left side, it is the root of logarithm. We cannot do anything, right? We do not have property for that root, all right? So in order to eliminate this root, Shabab, we just need to square both sides. Square both sides. What do we get? Let's square both sides, Shabab. So when we square both sides, clearly this square root will be cancelled by the square, right? And the square of negative 1 over 2 will be 1 over 4. So you'll get 1 over 4 times square of logarithm x. All right, square of logarithm x. And then just multiply both sides by 4, right? Both sides multiply by 4. And if you remove the 4 logarithm x with base 2 on the other side, you will get logarithm x square minus 4 times logarithm of x equals 0. Something looks like a quadratic equation, Shabab. And clearly here, logarithm x is common factor. Take the logarithm x as a common factor. So we have logarithm x minus 4 multiplied by logarithm x equals 0. All right. And now we have two options. Logarithm x equals 0 means the x is 1, and logarithm x equals 4 means x is equal to 16. Now which one is accepted, which one is rejected, Shabab? We just need to check it. If you replace x with 1 in the original equation, you just need to come to original equation, Shabab. All right. Replace x with 1, you will get logarithm of 1 is 0, so root of 0 is 0. On the other side, logarithm of root 1, well, it is 1 again. And logarithm 1 is 0. Negative 0 is also 0, of course. So 0 is equal to 0. So it satisfies the first original equation. So x equal 1 is okay. But how about if x is 16, Shabab? On the left side, we have logarithm of 16, which is 4, and root of 4 is 2, of course. So we have 2 on the left side. But on the right side, we will get negative 2. Because root of 16 is 4, and logarithm 4 with base 2 is 2, but we have negative here. So the left side is positive 2, and the right side is negative 2. They cannot be equal. So therefore, Shabab, the 16 is rejected. The only solution is x equals 1. And in the next question, maybe let me write one step for you. This 3, here, this is the power of x, not the power of logarithm. So it is a power of x. So this 3 comes behind the logarithm. So it is 3 times, right? 3 times logarithm x is equal to logarithm x squared. All right. After that, you can move the 3 logarithm x on the other side and take the logarithm x as a common factor, just like what we did in the previous example. And you will see the solutions show up. And then please do not forget to check your solution. Okay, before I continue, Shabab, do you guys have any problem, any question?
Doctor?
Yes, go ahead, please.
Can we distribute the square on logarithm x to the base 10?
Can we distribute the square?
Yeah.
Which square are you talking about, Shabab?
Whether the first one or the second one, the first question or the second question. The square root to all of the logarithm, can we distribute it? the square.
Square of this one, huh? Yeah, am I understanding you properly?
For example, the second one, doctor.
Here.
Yeah, can we distribute it?
How yani?
Like,
Let
for
me
example,
see.
can we say logarithm x squared to the base 10 to the base square root of 10?
Logarithm of x square and
to the base
10
square
square.
root, no, square root of 10, for example. Can we
Square
say
root
like
of
that?
10. Yeah, so well, we need to just make sure that is it according to any property of logarithms. We just need to go back and we just need to ask yourself, am I just following any property or something? If you say no, that means basically we cannot do that. So this is basically, Shabab.
Yes, doctor. I think isn't that the same as the logarithm of b to the power of n, the logarithm of x with base b to the power of n equal to 1 over n times logarithm of x to...
Yeah. So again, let me just write the correct one, Shabab. You guys can follow. That means logarithm of x multiplied by logarithm of x, Shabab. That square means logarithm of x times logarithm of x. That's all we can do. There is no other property, Shabab. There is no other property. Please make sure that you are memorizing the properties, Shabab.
Okay, right. Thank you, doctor.
Yeah, yeah. Okay, Shabab, it is good that you guys are asking. Nice. Let me see what we have here. Shabab, in this case, we have this part here, logarithm of 10 to the x, right? What was that? Logarithm of 10 to the x is equal to what?
X.
X. This is the property, you see? We are following the property. If you have logarithm 10 to the a will be equal to a, right? This is the property. How about this one, Shabab? We have 10 to the logarithm of a is what, Shabab? Do you remember?
Logarithm of x اللي هو a.
It is equal to a. Now what is a here? A is here, logarithm x, right?
X.
So result is logarithm x, Shabab. You see? So we have logarithm x and plus logarithm x. So clearly it is equal to 2 times logarithm x. All right. So let's just cancel the 2 from both sides, Shabab. We just cancel the 2 from both sides. We get logarithm of x minus 2 equals logarithm of x. And now, again, by the property of logarithms, the arguments should be equal. X minus 2 should be equal to x. What do you think about this equation? X minus 2 equals x, Shabab?
It has no solution.
Yeah, that means negative 2 equals 0.
Yes, which is not correct.
Of course. So there is no solution for this logarithmic equation, Shabab. Yes, sometimes there is no solution. It is normal. It doesn't have to have a solution. No. Okay. Let's see what is next. Well, this is quite simple, Shabab. I'm going to leave it to you. Yeah, this is another standard simple question. Well, here we have no base problem. We have the same base, but only thing we have is 1 over x. Well, if you write instead of 1 over x, if you write it x, Shabab, you see, you will get plus here. Because if you change 1 over x to x, that means you need to multiply logarithm with minus. There is another negative here. Negative times negative is positive. So again, let's just remember the one property of logarithm, Shabab. It is the same as, right, negative logarithm of x base b. Is that clear, Shabab? You see, we are following basic properties. So we get logarithm of 5x minus logarithm of x minus 20 with base 5 plus logarithm of x with base 5 equals 3. Of course, it is a sum of the logarithms going to be the logarithm of multiplication, right? We need to multiply the arguments. So x times x minus 2 will be x squared minus 20x equals 3. So after that, Shabab, I'm sure you guys can easily follow the rest of the solution. X squared minus 20x will be equal to 5 to the power of 3 is 125. Am I right? So you just need to solve this quadratic equation, and then after you solve it, please check your solution with the original equation, Shabab. All right. Well, let's see what is next. Well, we have no base problem here. This is base 8. That's base 8, so you know what to do next. Here we have logarithm of 16 with base 4. This is 2, of course, right? It is equal to 2, Shabab. And now you just need to multiply, Shabab, the arguments. X plus 5 times 3x minus 1 with base 8 equals 2. And the rest is, I guess, is going to be easy for you. X plus 5 times 3x minus 1 equals to 8 to the power. It is 64, huh, Shabab? All right, so I'm sure the rest is clear for everybody, Shabab. And please do not forget to check your answer, huh, Shabab? Okay, let's see if there is anything interesting. I would suggest just move this negative ln2 to other side, so it will come here plus ln2. So after that, you need to multiply the arguments. 2x plus 5 over 2 multiplied by 2, right? If you move this one to other side, Shabab. This is, I would suggest you to do that. In the other question, there is no base problem. It is the same thing. So it just multiply the arguments and follow the regular properties of logarithm. All right. Here, the first question is standard. I guess you can do that. The second question here looks like we have a logarithm of logarithm. Well, first, look at this part, Shabab, right? Now, this part, logarithm base 2 x squared minus 1 is equal to 3 to the power 1, which is 3, right, Shabab? Right? After that, another basic logarithm property we need to use. X squared minus 1 equals 2 to the power of 3, which is 8. So x squared is 9. So x will be equal to positive or negative 3. All right, so let me see, guys, if you have any question. All right, these kind of standard power exponential equations, Shabab, we have already solved these things. Let me see if there is anything interesting. Maybe I should just look at here. Shabab, 9 to the power of x, so we have 3 to the 2x, am I right? Minus 2 times 3 to the power of x plus 1 means 3 times 3 to the power of x, am I right? Equals 27. So now, did you guys understand 3 to the power of x plus 1 is the same as 3 times 3 to the x, huh? So what we got here, 3 to the power of 2x minus 2 times 3 is 6. 6 times 3 to the power of x, and then minus 27 equals 0. Again, if you say let's just call 3 to the x as y, right, Shabab? This substitution. So 3 to the power of 2x will be y square, of course. Y square minus 6y minus 27 equals 0. Okay. Now, after that, Shabab, I'm sure you guys remember how we solved the exponential expressions
Y
like
minus
this.
9 and 3.
Yeah,
Y minus 3.
Yeah. What is the problem here? Well, we have 1 over 4 here, Shabab. It can come as a power of 81. So it becomes what? Logarithm of 3, correct?
Yes.
Base x and plus logarithm of x plus 6 and base x again equals to, well, negative ln 1 over 2 is the same as ln 2. You guys understand it?
Yes.
Is it clear?
Yes.
So now you have e to the ln 2. What is e to the ln 2, Shabab?
2.
2. Perfect. So basically we have 2 here. Now we have logarithm plus logarithm. That means you need to multiply the arguments. Logarithm, so 3 times x plus 6 is 3x plus
18.
18. Perfect. And the base is x equals 2. Right? Now let's write it in terms of exponential expression, Shabab. So we have x square, right?
Yes, equals
Base
3x.
Equals 3x plus 18.
We move them to one side, to the left side.
Yeah, x squared minus 3x plus, I'm sorry, yeah, minus, yes. Minus 18 equals 0.
And we solve it as a quadratic equation.
Yes, we have x minus 6, x plus 3, huh, Shabab?
Yes.
So we have one option is 6, another option is negative 3.
Yeah. And it wants the sum of them.
Of course, Shabab, negative 3 is rejected clearly, sir.
Negative.
Why it is rejected, Shabab?
Because the x cannot be negative in the logarithm.
Yeah, we have base. Base is x. In this
Yes.
case, we have base is x, so base cannot be negative. So
The answer is 6.
only 6 Shabab.
Yes.
Yeah, correct answer is A. Yeah.
Doctor,
Go ahead.
why the bases can't be negative?
Well, then we need to go all the way back to exponential rules and logarithmic rules, Shabab. This is the rule of base. Base is positive, but not 1. Okay? This is the rule, Shabab. This is the rule for the base. Positive, but not 1. All right? Okay. Okay, sure. Next. Well, it is, of course, impossible to finish all the questions, Shabab, and they are waiting for you as a practice, right? As a practice question, Shabab. So we are going to start, inshallah, our new section. New chapter, basically, chapter 4.5.1. Okay, let's start our new chapter. All right. Now let's talk about the angles, Shabab. The angles. Right? We have to pronounce as angles, not angels, huh, Shabab? It is angle. So who's going to tell me what is the angle in Arabic, Shabab?
Zawiya.
Zawiya. Perfect. Yes. Of course, you learn the angles in high school. To which level, I don't know, but you must have some information already in your mind. So if somebody asks you what is the angle, Shabab, the angle is basically rotation of a ray about the vertex. So in the picture, you see the ray, Shabab. Ray means it's just a line starting from one point and going to, one side here. So if we rotate this line about the vertex, then you're gonna get the angle. So let's rotate it now, Shabab. You see? That makes the angle. And for the next, all right. The first position, which was on the red line, of course, is called the initial side. All right. And the last position, which is the blue line, is called a terminal side of the angle. Initial side and terminal side. And now let's talk about the positive angles and negative angles, Shabab. For the positive angles, just a second, I'm sorry for this. Okay, let's start again. Depends on the rotation, the direction of the rotation, Shabab. if the rotation is opposite to clock rotation, counterclockwise, then we are going to call it positive angles, as in the example, Shabab. So this is the opposite of clock, right? So it is called the positive angle. But if you rotate it just like a clock, that means clockwise, you're going to get the negative angle, as you see in the picture. So you have the negative angle like that. It's just a matter of the direction of rotation, Shabab. Opposite the clock is positive direction, positive angle. Just like the clock, it will give you the negative angle. All right. That is why we call it positive angle and negative angle. Depends on the rotation, Shabab. And now, if you rotate one complete rotation, Shabab, as you see, one complete rotation. So we will measure it as a 360 degree. All right. One full rotation. Of course, then if somebody asks how much is 1 degree, well, you need to divide 1 over 306 of the complete rotation will give you 1 degree. And as you guess that it is a very small angle, of course. So that is the measure for the angle, Shabab. We have one measure is degree measure, is like a meter, a kilometers, or meters, miles, inch, whatever. So different kind of measures, right, Shabab? So for the angles, we have a degree measure. Also later on, we are going to learn a radian measure. We have the one more measure, but it's not quite common in our study. So you will learn it in your advanced studies in Jebel. Maybe there is another the degree measure. So for the 90 degree, Shabab, 90 degree, we are going to call it a right angle. The name of the 90 degree is a right angle. But if something is less than 90 degree, but positive, of course, so we will call it acute angle. Now, who's going to tell me what is the acute angle in Arabic?
زاوية حادة.
Zawi hadda. You guys will learn it?
Yes.
Yes, yes.
Zawi hadda. Okay. How about right angle, Shabab?
زاوية قائمة.
زاوية قائمة.
Zawi qaima. Yes. So if something is 180 degree, right, angle, then we will call it straight angle in English. In Arabic, zawiya mustaqima.
Yes.
Yeah, I think so.
You see? Okay, how about obtuse angle? Obtuse angle is less than 180 but greater than 90.
زاوية منفرجة, I think.
زاوية منفرجة. Yeah. Looks like you learned a lot about angles in high school, sir.
Yes.
Okay. Now we have another names, Shabab, complement of an angle and the supplement of an angle. So what does it mean? We have two positive angles, alpha and beta, and the sum of them will be 90 degree. Alpha plus beta is 90 degree. Then we will say they are complementary angles. So one is complement of the another one, right? Like a 50 plus 40, for example. 50 plus 40 is 90 degree, right? So 50 is the complement of 40, and 40 is complement of 50, like that. Or 60 plus 30, right? And the supplement of angle, So we have the same angles. If the sum is 180, so we will call it supplementary angles. For example, 20 and 160. So 20 is the supplement of 160, or 160 is the supplement of 20. Right? So it's just names for these the angles. They are positive, of course. We are not using negative angles for these complement and supplement issues. Sure. Yeah, there are some examples, as I told you, Shiva. A complement and supplement of angles. And now let's remember these pictures. Imagine if I ask you this picture, how much is the value of x, Shabab? Who's going to tell me?
The first one?
Yeah.
We can say 19 is equal to 5x plus 4x, which is 9x. And then we divide both sides by 9. So x is 10. And then we multiply 10 by 5 to find the first angle, and multiply 10 by 4 to find the second angle.
Yeah. So in the first picture, x is 10 degrees, right? It is so simple to find, right, Shabab?
Yes.
X is 10. How about the second picture?
Same method, but it's equals 180.
Yes.
180.
Also 10, right, Shabab? So can you believe that we asked questions like this in the major exam, Shabab?
It's a gift.
It is a gift, exactly. So we have a question in the major exam like this. Okay. Well, a degree and minutes and seconds. It is like a hour, minute, and second for the time, you know, to measure the time. For long times, we have to say hours. But if it is too long, we have to say days. If it is longer than a day, we would need to say weeks, right? To measure the time. But how about very small, short times? We are using minutes. And if the time is very, very short, then we have to say seconds. And even less than seconds, times possible, right? In the science, you know. So in the angles, we are using the same names, Shabab, minutes and seconds for the small angles, very small angles. Imagine how small is 1 degree already, right? 1 degree is already quite small angle. And now just divide the 1 degree with 60. So each of them will be 1 minute of angle, 1 minute angle. You see? So 60 minute is the same as 1 degree angle. It's like a 60 minute is 1 hour, right? It's like in the time. So in the angles is the same thing. 60 degree, 60 minute angle is just 1 degree. And imagine how small is one minute angle. You see, 1 minute is equal to 1/60 degrees, Shabab. Of course, 1 minute is equal to 1/60 hours, right? 1 minute is 1/60 hours. It's the same thing. A degree is like an hour in the time. And also we have seconds. We have 1 second, right? We are using a double prime for seconds, and we are using just 1 prime for the minute. So it is 1/60 minute, or 1/3600 degree. Yes, it is like in the time, 1 second time is equal to 1/3600 hour in terms of hour, right, Shabab? And 60 seconds is equal to 1 minute, of course. Okay. So, for example, if I ask you how much is 0.5 degree, how can you write it, Shabab, in terms of minute?
We can multiply it by 1/60.
Yani, okay.
30.
30 what? Minute, right? Of course. Yani half hour is 30 minutes, Shabab. Is it like this? So half a degree is 30 minutes, right, Shabab? How about 0.25 degree?
15 minutes.
Like this. 15 minutes. Like this, Shabab. All right. Now, to study angles, Shabab, we need to establish a standard form. When we draw the angles, we will assume that always the initial side on the positive x side. Okay, positive x line is going to be the initial side. That means always you need to start from here. And then if you go to direction, positive direction, you go to counterclockwise. Negative direction, you can go to clockwise. But the initial side is always on the positive x line, positive x-axis. The vertex is origin, of course. Vertex is the origin. Now, in the first picture, for example, the terminal side is inside the first quadrant. Terminal side. That means we will call it 60 degree is in the first quadrant. We remember the quadrants, right? First quadrant here, second quadrant, third quadrant, fourth quadrant, right? So now we are going to say a 60 degree is in the first quadrant. In the second picture, for example, we have 110 degree. Looks like the terminal side is in the second quadrant. So we say 110 degree is in the second quadrant. So it depends on where is the terminal side, second or third or fourth quadrant. But how about 90 degree, for example, Shabab? Who's going to tell me where is 90 degree? Is it in the first quadrant or second quadrant?
It's on the y-axis.
Yeah, 90 degree, right, Shabab? Terminal side is on the y line. Exactly on the y line. So can you say it is in the first quadrant? No. Second quadrant? No. It is right in between, right? So we are not going to say 90 degree is first or second. 90 degree is what did we say? I'm sorry. Quadrantal angles. I'm sorry, I confused the name. Quadrantal angles. So just like in the 180 degree, 180 degree, and the terminal side lies on the y-axis again, exactly. So it is not in the second quadrant or not in the third quadrant. So we say it is right between second and third. Again, same name, quadrantal angles. And similarly, 270 degree and 360 degree and so on. Okay, as long as terminal side is exactly between two quadrants, so it is called quadrantal angles. All right. Now here is the famous topics, Shabab, coterminal angles. So we know the terminal side So if two angles or three angles, whatever, if they have the same terminal side, then we will call them as coterminal angles. Coterminal angles. For example, in the first picture, we have 60 degree and 420 degree. They are coterminal. You see, how do we get 420, Shabab? 420 is one full rotation, 360, right? 360 and plus 60 will give you 420. So the 60 degree and the 420 degree, they will stop at the same terminal side. All right? So they are coterminal. And similarly, Shabab, we have 830 degree. How much is that? Well, it is one full rotation, 360, another rotation, 720, right? 720 and 110 plus 110 will give you 830. So you see 110 degree and 830 degree are coterminal angles. Now here is the idea, Shabab. When we have the 420 degree, how do we find the 60 degree? If I give you 420.
Subtract 360 from it.
Aywa. If you subtract 360, you will get 60 degree. Or, Shabab, or if I give you 60 degree, how do you find the 420? Add. Add 360. So it looks like this is the idea to find another angle. When I give you a certain angle, so what you need to do, you need to add 360 or you need to subtract 360. Depend on the question. You see? Now, if I give you 830 degrees, Shabab, how do you find the 110? Well,
subtract 720.
Yes. Subtracting 360 is not enough, right? So you need to subtract another 360. Means 2 times 360, yani 720. All right. So this is the idea of coterminal, Shabab. You just need to add or subtract 1 360 or 2 360 or 3 or 4 times 360, as much as you need. All right. For example, 908 degree, and I like to find 188 degree. How can we find it? Well, it is 908 degree, and if you subtract 2 times 360, it will give you 188. So when I give you 908 degree, your job is subtract 2 times 360. This is the question, Shabab. This is what you need to remember, how to find the coterminal angle.
And when do we add 360?
When do we add 360? Well, if you like to find the bigger angles, larger angles, so?
But here is the wider angle is 908. If I add 360, it will be 1. How do I know if it's more than 360?
If you add 360, Shabab, right?
Yes.
908 degree plus مثلا 360. How much is this? 1200, right? 1268 degree. Okay. This is also another coterminal angle.
So I find them all, or how? When you ask me, or I find
No.
the first one.
As I said, depends on the question. You see, look at the question here. Find the angle of
Least positive.
Least positive. Yani don't go too much.
Okay.
Least positive. Mesela şebap 908 minus 360 is not going to be the least positive. So if you subtract 360, it is not enough, right?
Yes.
So it should you should subtract 2 times 360, so you will get the least positive angle.
Yes, I get it now.
Very good. Perfect.
Thank you, doctor.
Eyvah Şebap. So we just need to read the question, Şebap. Whatever they ask, so you need to add the 360 as much as needed, or you need to subtract 360 as much as needed. Let's see if we have one more. Well, in this case, for example, we have negative 75 degree. If you add, you will get positive 285. So positive 285 and negative 75 are coterminal, you see? So in this case, we add 360 to find the least positive, least. Because if you add more instead of 360, another 360, yani 720, you will get a larger angle, right? No, we don't want a larger angle. We want the first positive angle, first one. So which is 285. So that's why we call it least positive, yani the first positive angle.
Doctor?
Yes.
I have a question about the quiz. It's on Thursday, 6 o'clock, right?
Yeah, some of your friends, Shabab, they said they have another exam or there is another class or something. So
Yes,
they are asking for 7 p.m. or 7:30 p.m. if it is okay for you guys.
Because I have lab on Thursday. It will end about 5:10 or something, and the university is a bit far from my house, like 1 hour drive or half-hour drive. So I want to be sure if I'm gonna be able to be home at 6 exactly.
Yeah,
so I ask if you can make it 6:30 or 7.
Yeah, that is a couple of more students also ask the same problem, inshallah. We'll adjust the time, inshallah. Don't worry.
Okay, thank you, doctor. Have a nice day.
Yes. So inshallah, we should stop here and we'll continue from this page, inshallah.
Doctor.
Yes.
Yes, I think it's a good idea to put a specific time for all the quizzes, because if we change the time every time, it's not a good idea.
Of course, that would be much better, but Shabab, the problem is, for example, in this case, looks like some students, they already forgot their schedule and they did not tell us that they have another schedule, so it will be difficult, or so when we set up a certain time, definitely it will conflict with the other schedules of class. Your schedule is so tight, so sometimes setting the certain time is going to give you more trouble, actually. So that's why we are going to be flexible about quiz time, to not to make you squeeze too much. If you have anything to do at the same day and close times, then we will just change it, inshallah.
All right. Thank you, doctor.
Thank you.
I'll see you guys, inshallah.
Inshallah. Goodbye.
All right, you too, Shiva. Bye.